Hi everyone, today we're going to be talking about the idea of combining like terms and using the distributive property to help us solve equations. So first we're going to learn how to combine like terms and then how to use the distributive property. Go ahead and follow along with your notes with me. Like terms are terms that have the same variable and the same power. So that means if I have something like 3x and 5x, those are like terms. But now let's say if I have 3x squared to the second power and 5x, those are not like terms because this one has a second power and this one has an invisible first power. Okay? So let me do a few examples of that. So let's say I have 3y to the second power and negative 5y to the second power. They have the same variable and they have the same power, so they are like terms. But now let's say I have 3y and negative 5x. Those are two different variables, so they are not like terms. Okay? Let's go over some of these examples. So when combining like terms, you want to use the sign, meaning positive or negative, before, that means to the left of the term, to add the terms. Okay, so let's take a look at example 1. It says negative 4x plus 3 plus 7x. Alright, so now I'm looking at this and I notice that there are two terms that have an x. So I see this negative 4x and I see this positive 7x. Notice when I box them up that I'm also boxing up the sign before it. So this is negative 4x and a positive 7x. Okay, so if I was to combine terms here, that means that I'm doing negative 4x plus 7x and then a plus 3 is at the end. So negative 4x plus 7x, it means negative 4 plus 7 gives me a positive 3x, and then I'm just going to bring down the positive 3. At this point, I ask myself if I see any other like terms. So now one of the terms has x, but the other one doesn't, so they are not like terms, so I'm just going to leave it as 3x plus 3. Okay? So let's try example 2. Again, I'm looking through each of these terms and determining whether or not they have the same variable and the same power. So I see negative 3x to the second power, positive 5y, negative 1, and negative 2y. So I notice that positive 5y and negative 2y are like terms because they have the same variable and the same power. Everything else I'm just going to bring down, so negative 3x to the second power, positive 5, subtract 2, that's a positive 3y, and then I'm going to bring down my negative 1. Now I ask myself again if I see any like terms. Well, I see an x to the second power, that's not the same as y, and that's not the same as the negative 1 that has no variable. So that's my final simplified expression. Negative 3x squared plus 3y minus 1. And here's the final example. If you want to pause here and actually try it on your own, feel free to do so. So here's the third example. It says 3n subtract 5z, add 6y, subtract 2z. So again, I see two of the same variable, and they both have the same power. So I've got negative 5z and negative 2z. Everything else I'm just going to bring down. So I've got 3n, negative 5z, subtract 2z, makes a negative 7z, and then plus 6y. And now all of these are unlike terms because one has n, one has z, and one has y, all different variables. So that's as simple as I can make it. 3n subtract 7z, add 6y. Okay, so that's how we work with like terms. Now we're going to be using that skill to help us out in solving equations, so you want to make sure to remember that as we move along here. Okay. So now the second skill that we're going to be learning about is the distributive property. The distributive property allows you to multiply each addend of a sum or difference. So that means if I have 5 add 7, this is an addend, and this is an addend. It's basically a term for the things that you are adding, okay? Or subtracting. Okay, so let's look at example 1. So this says 2 parentheses x minus 3. So that means 2 is going to multiply the quantity of x minus 3. So what I can do here is I can multiply the 2 by the x and then multiply the 2 by the negative 3. So I'm going to make this absolutely clear and actually write that out. So 2 multiply x and 2 multiply negative 3. Okay? So now at this point, I can simplify things. I can say 2 multiplied by x, that's just 2x, and 2 multiplied by negative 3, that's just negative 6. These are not like terms, so I can't simplify it anymore, and that's my expression. Okay. Now example 2 is only slightly different. It says 2x plus 5 multiplied by negative 3. So in this case, the negative 3 is what you're going to multiply by each of the terms in the parentheses. So I'm going to say 2x multiplied by negative 3, and then positive 5 multiplied by negative 3. Remember, it doesn't matter if it's on the left or the right, since multiplication is commutative. What that means is that 2 times 3 is the same thing as 3 times 2. So if I take this 2x plus 5 times negative 3, that's the same thing as negative 3 times 2x plus 5. Okay, and now I'm going to simplify. So 2x multiplied by negative 3, that makes negative 6x. And positive 5 multiplied by negative 3, that's negative 15. I'm going to go ahead and box that up, and that's my simplified expression. Now if you want to try example 3 on your own, feel free to pause and try it on your own. Otherwise, I'm going to go ahead and do it. So in this situation, I'm going to multiply 4x by x, and then 4x by negative 7. So I'm going to write that out. So that's 4x multiplied by x, and 4x multiplied by negative 7. Now here, we see x times x. X times x, if you did not know, is x squared. So that means that this is equal to 4x squared, and then 4x multiplied by negative 7 is negative 28x. Okay, so that's how we use the distributive property. Now these next few examples are going to be using like terms, using the combining of like terms, and using the distributive property to actually solve equations. Okay, so when solving equations with like terms, you want to first combine the like terms and then just solve it like a one-step or a two-step equation. So I look at example 1. The first thing that goes off in my head is I want to find the middle of my equation, which is the equal sign. Next thing is that I want to label my variable, which is x. Right? And you might notice that you actually see 2 different places where you see the x here. Now that's convenient because we just learned how to combine 2x and negative 5x. So 2x and negative 5x are like terms, so 2x minus 5x gives me negative 3x. Now on this side I'm just going to bring down to 12, and I'm going to keep going. This means negative 3 multiplied by x is equal to 12. Well here I can use my inverse operations. Inverse operation of multiplication is division. So I'm going to divide negative 3. This creates 1x is equal to negative 4. Okay. Example 2. Same thing. I'm going to find my middle of my equation. I'm going to identify my variable, which is y in this case. I'm going to see if I have any like terms. I notice that I have like terms. I have negative 3y and a positive 9y. So if I add those together, I get a positive 6y. Again, I'm down to a one-step equation that is being multiplied. So I can use the inverse operation, which is division. I've just created 1y equal to 3. Okay, and again, this is a spot where you can pause and try example 3 on your own, or just follow along with me. I find my middle, that's the equal sign. I identify the variable, that's n. I find my like terms, which are 3n and negative 7n. When I combine those, I get a negative 4n, which is equal to 16. This means that I'm multiplying negative 4 by n, so I'm going to use the inverse operation, which is division, and divide a negative 4. Divide negative 4, that creates 1n, which is equal to negative 4. Okay, and then we're going to do our last set of examples, which involve the distributive property, and that will be the end of the video. When solving equations with the distributive property, you want to distribute and then solve like a one-step or two-step equation. Okay? So I look at example 1. Same things go off in my head. I see the middle of my equation at the equal sign. I see my variable, which is x. Except in this case, I see a number outside of parentheses, meaning that I could actually distribute it into the parentheses. So that means 2 multiplied by 3x, that gives me 6x, and 2 multiplied by negative 1 gives me a negative 2, which is all equal to 10. Now here, I'm in a similar situation as homework number 19, or notes number 19, and I could use the backwards order of operations SADMAP. Okay, so I'm going to start on the side of the variable. Do I see subtraction? Yes. The thing being subtracted is the 2, so I'm going to add 2, use the inverse, that creates 0. I want to create balance, so I add 2 on the other side. So now I've got 6 multiplied by x equals 12. I keep going through. Do I see addition? No. Do I see division? No. Do I see multiplication? Yes. I'm going to divide to use the inverse operation of multiplication, and I end up with x equals 2. Okay, for example 2, again I find my middle, which is the equal sign. I identify my variable, which is n, and I determine whether or not, well, what goes off in my brain is that I see this number outside parentheses, so I can distribute into the parentheses. So negative 3 multiplied by n is negative 3n. Negative 3 multiplied by 5 is negative 15. Now I've got negative 12 here. Now I'm in a situation where I can again use backwards order of operations, SADMAP. Do I see subtraction on the side of the variable? I do. The thing being subtracted is this 15, so I'm going to add 15. That means I need to add 15 on the other side of the equation, which leaves me with a positive 3 equal to negative 3 multiplied by n. Do I see addition? No. Do I see division? No. Do I see multiplication? Yes. So I'm going to divide by negative 3, divide by negative 3, which creates 1n is equal to a negative 1. Okay, and again, final situation where you can pause and try it on your own if you choose to. Otherwise, just follow along with me. Equal sign is the middle. My variable is z in this case. And I see this number outside of the parentheses, so I want to go ahead and multiply inside. So 5 multiplied by 2z gives me 10z. And 5 multiplied by negative 3 gives me negative 15, which is all equal to negative 20. I'm going to use SADMAP again. Do I see subtraction on the side of the variable? I do. The thing being subtracted is this 15, so I'm going to go ahead and add 15. I'm going to add 15 here. That creates a 0 pair. So now I've got 10z equals negative 5. I'm going to divide by 10, so that's the inverse operation of multiplication, which gives me z equals negative 5 over 10. Now I can simplify that to z equals negative 1/2. And that's it for today. If you have any questions, please come in to tutoring or office hours.